In this video, we'll be talking about rollback, or really, what do you do when you need to abort a transaction? What do you do when you realize you aren't going to be able to commit the transaction to the database? Now, this can happen for a number of reasons. So, for instance, when would you want to abort a transaction? So, one reason you want to abort a transaction, if something goes horribly wrong. For instance, if the power fails on your computer, you'd want to abort all the transactions that are currently going on because there isn't a good way to recover from a state like that. Or if an exception or error occurs, if somebody types in a SQL statement that's illegal, you might want to abort that transaction and say, hey, start again. Or if they try to do something that's not allowed, like to try to change part of the database that user doesn't have permission to change or something like that. You might want to abort if your computer runs out of space, right? There's no room to add the modifications to the database. A big reason is if you can't complete the transaction for some reason. For some reason, the transaction isn't able to be finished, and you need to undo it because you need to maintain atomicity, either all or nothing. Abort is how you get to the nothing state. If any of these things happen, you need to do what's called a rollback. So, as I said before, a rollback can occur for many reasons. Sometimes the database causes there to be a rollback because it's like, I can't give you the locks that you want. You're going to have to roll back. Try again. Sometimes the users call rollback. There's a rollback SQL statement that says, oh, if you realize you don't want this transaction to actually commit, you need to roll it back. And in many times, a rollback is the only way to fix some of these problems. And so when a rollback occurs, all the modifications to the database that have occurred since the transaction began need to be undone. Once again, for the atomicity. So what would this sort of look like? Well, here's a transaction that has a rollback in it. So I create a table called students. I begin a transaction. I insert into the table students the value Josh. And I go, oh, shoot, Josh isn't a student. I should not have done that. That was bad. So I'd say rollback transaction. And then if I do select statements, it won't show that Josh is in the database because that change to the database, adding Josh to the table students, was never committed. It was rolled back instead. All right, so that sounds all well and good, except rollbacks can have a pretty terrible consequence. So let's go to a multiple choice question. So here we have 3 transactions that are getting exclusive locks and getting shared locks, doing reads and writes. And I can promise you that these schedules, and if you want to, you could write a little program or run it through by hand, follow all of the rules for schedules, for conflict serializable schedules. They have consistency of transactions, they have legality of schedules, and they adhere to the 2-phased locking commit. All right, so is this schedule legal? So, is this schedule legal? Yeah, it follows all of the rules. Okay. However, let's say, for instance, transaction 1, down at that last stage, decided it needed to roll back for some reason. Like it decided, oh, you know what, I want to undo what I've been doing. So if there's a rollback right where I've listed it, which transactions need to be rolled back? So the easy answer here is transaction 1 definitely needs to be rolled back. It's the one who called rolled back. The tricky thing is transactions 2 and 3 also need to be rolled back. Why is that? Well, let's look at what's going on here. So right here we have the we're doing a write to A, and then we're doing other things. And then transaction 2 here is doing a read from A. So if we need to roll back transaction 1, we need to undo that write. Right? Like say it added Josh to the table of students. But transaction 2 here read from A, and the big problem here is it read from A, and so it actually read bad data. It read data that was dirty, data that it should not have been able to read because this transaction, it needs to be rolled back. So in reality, transaction 2 is now corrupted as well by now bad data. And transaction 2 writes to database element C, and transaction 3 here reads from database element 3C after transaction 2, which it's allowed to do, but because transaction 2 read from database element A, and perhaps it used database element A to help decide what it should write to C, transaction 2 is now kind of corrupted, and it means that transaction 3 also read data that could have been screwed up by transaction 2 because it was corrupted, and so this kind of transaction 1 is now bad data, which messed up transaction 2, which messed up transaction 3. And so what transactions here need to be rolled back? Basically everything that was ever touched, anything that transaction 1 wrote to. Any transaction that could have seen the writes that transaction 1 did. Or this guy could have seen the writes that transaction 1 did. And these two transactions could have seen those writes because transaction 1 unlocked A. Okay, so this problem of if you need a rollback violating isolation is a problem of what's called dirty reads. If a transaction has read modified but uncommitted data from a transaction that's rolled back, it is now dirty. And so the solution to that is you need to roll back that transaction as well. It may not have used that dirty read to affect its writes, like it may have just read data there and didn't use that data, but the thing is you can't be sure exactly how the transaction calculates what it needs to do for its writes. So anything that reads dirty data needs to be rolled back as well. And this can lead to a problem that's called a cascading rollback, which means that, by having to roll back one transaction, you need to roll back another transaction, another transaction. You need to roll back sometimes all of the transactions that are ongoing in a particular database. And so this can be a problem, but I mean, in reality, the database never promised that once you start a transaction, you'd be able to commit. It just promised that you'd either be able to commit or nothing would happen at all. So the database uses this ability to roll back other transactions to ensure safety. So once again, the database, the only promises it makes is that that transaction will either commit or be rolled back. And if the database has to roll back other transactions for safety, it will do so. Alright, so this is actually a huge problem, these cascading rollbacks, because if rollbacks aren't necessarily very rare things, you could roll back every time you couldn't get a lock that you wanted, and you wouldn't want to completely screw up all the ongoing transactions and roll back them as well. That's a painful and expensive thing to have to do. So how do you avoid cascading rollbacks? Well, the solution actually isn't too hard to do. It's what's called enforcing strict two-phase locking. So we've talked about two-phase locking before, that you always have an expanding phase where you're acquiring locks, and you have a shrinking phase where you're releasing locks, and you're not allowed to overlap those two phases. But a strict two-phase locking has a slightly different rule. Locks are only released at the moment you commit, or the moment you roll back, never before. So it's saying at the moment that you want to do a commit, that is the one time when you release locks. And so what happened here, the big problem with this schedule here, was the fact that transaction 1 unlocked the A here before it actually did its commit. And so what that meant is that there is all of this time after it's released its lock on A and let other people read from A or write to A before it did its rollback. And so if it had done its commit up here right when it released A, none of these other things would have happened, because then if it rolled back, it would only have affected itself. And so this is actually the trade-off here. So by enforcing strict two-phase locking, you make sure that you don't get these cascading rollbacks, because nobody else is allowed to see, read your write until you've actually made your commit. And so that saves from cascading rollbacks, but the problem is that means that it heavily constrains what sort of work this transaction can do. It means after it's decided to release its first lock, it's not allowed to do any more work after that, which heavily constrains the sorts of schedules you can generate, which in turn constrains how good you can optimize these schedules to allow for multiple people to be doing different things at the same time. So this is the trade-off. Strict two-phase locking, this needing to release your locks at the moment of commit and never before, slows down throughput. It means transactions aren't able to overlap with each other as much, but it means that you don't get these cascades. So which one do you care about? It's really up to you. In this class, we'll be basically only doing strict two-phase locking because it makes your life a whole lot easier. If you don't have to worry about cascades, you don't have to worry about which other transactions may have read your dirty data. Because there is no dirty data ever. You always release your locks when you commit. You never have to worry about other transactions seeing that dirty data. SQLite actually for the has kind of two different modes for you to do this, but for the purposes of this class, we are only going to do strict two-phase locking. Okay, so how do you implement a database rollback? How do you undo the changes to the database? Well, there's a couple of different ways. I'm going to talk about two of them that are easier for you guys to commit. In reality, the way that different database management systems handle rollbacks is actually an incredibly complicated topic. They use bit fields to say which rows have been modified or which tables and such have been modified by each database, and they store the old version of the database for restore purposes, and they keep track of which transactions have read which data at what version of the data to see if they need to be rolled back. It's actually a very complicated topic, which you could read about on your own if you want. But for the purpose of this class, the easy way to implement rollbacks is one of these two methods. Either you keep an old copy of the old data whenever you're modifying the database in a transaction. So you keep an old copy that's safe. And then when you need to do a rollback, you basically say, hey, take that safe version, make that the real version again. Replace the modifications that you made to the database with the backup. The other option is you make your modifications to the database on your own temporary copy. All right, so all of your writes and reads from the database for a given transaction are occurring on their own little version. And then when they actually commit, then they take their own special version and they make that the real one. And if they ever need to roll back, they just delete their temporary one. Both of these actions both of these different options ultimately end up being the same, especially if you're doing strict two-phase locking. So it's up to you to choose which of these is easier for you to think about, easier for you to reason about, which will be important because you'll need to pick one of them in order to solve Project 4.